We talked about how we could find all of these different area formulas for our quadrilaterals. Now that we know what they all are, today we're just going to be applying them to the actual figures themselves. Okay, so we'll be finding area for triangles, parallelograms, rhombi, trapezoids, and heights. So here you can see that first they remind us what the formula is for area of a triangle. We're going to fill in all of these blanks for each question. So the first one, F, just stands for formula. So the formula for area of a triangle, base, 1/2 base times height. And we're using it for this picture that's right beside it, okay? So they ask for B, which stands for base. What's the base of this figure? Very good. And what's the height of this figure? Okay, on the next line, they want you to show what it looks like when you plug those numbers in. So you would have 1/2 times the base, which is 12, times the height, which is 8. And then on the last line, you put your final answer. So we need to multiply those three terms together. 1/2 times 12 times 8, which would give us 48. Good. So my area is 48 inches squared. Okay. Same idea. Now I'm looking at this figure. It's still a triangle. So still the same formula. 1/2 base times height. What's the base of this figure? Good. Do we know the height? No, it would be this perforated or dotted line here. Okay, because it has to be perpendicular to the bottom. I don't know what it is, but I do know that this side is 5 and this side is 3, so what could we use to find it? Pythagorean theorem. And this is actually one of our Pythagorean triples. Anybody know what it should be? Okay, well, the hypotenuse is 5, so it can't be bigger than that. 4. All right, so height is 4. So I just plug that into the formula. 1/2 times base, which is 9, times height, which is 4. And then we just multiply those three things together. And what do we end up with? Very good. So 18 feet squared. That's my area for that. All right. On this figure here, still a triangle, so still the same formula. Do I know the base? Do I know the height? So we got to find both of those things. What kind of a right triangle is this?
30, 60, 90.
Okay, so I got a 30, 60, 90 triangle. What do we label the side across from 30?
X.
Good. Across from 60?
X 33.
And across from 90? Good. All right, which side did they give us? The hypotenuse. So which one of these three would that be? The 2x. Okay, so 2x is 12. So what does that mean x is? Good. And x squared root of 3 would be 6 square root of 3. All right, so here's the 30-degree angle. The side across from that is this one right here, which is, with the way this is drawn, probably what we would consider as our height, right? So across from 30, we said we labeled that 6, so our height is 6. The 60-degree angle would have to be here. The side across from that is the bottom, which is what we would consider to be the base, which we said was 6 square root of 3. So we've got 1/2 times 6 square root of 3 times 6. Okay, we want the exact area. So I cannot type that square root into my calculator because it's going to give me a repeating or a non-repeating decimal, something that goes on, right? What we call an irrational number. So I have to only multiply the numbers, right? We treat those radicals just like they're a variable. So basically pretend instead of 6 square root of 3, pretend that's 6x. I could still multiply 1/2 times 6x. What is 1/2 times 6? 3. And then 3 times 6 is 18, okay? So 18 square root of 3. This one didn't give us any units, so we're just going to say units squared. So when they say they want the exact, this is what they're looking for, no decimals. Well, no decimals that continue on, right? It's okay to have like 0.5 or something like that, just not something that you would have to round. All right. Okay, in this next section here, what kind of a figure is this one? Parallelogram, how do we know?
Sides are parallel.
Very good. Okay, and we were just reminded right here that the formula for area of a parallelogram is base times height. Okay, so what's the base of this figure? Right? Because in a parallelogram, we know that opposite sides are congruent, so if you want it to be the bottom, it still is the bottom. Okay, do we know the height? That would be this line right here. How could we find it? All right, we've got a 30, 60, 90 again. Very good. All right, so I got a 30, 60, 90. Like you guys said, we label those sides x, x squared root of 3, and 2x. Okay. What did they give us? Right, the 2x. Very good. So we know that 2x is 8, so what is x? 4. And in this figure, if this is my 30-degree angle, the height is the one across from that, so that's all we need, is the height to be 4. So then we've got base times height, which ends up being, very good. All right. Okay, on this second one, what kind of a figure do we have here? Square. We know it's a square because all sides are congruent and it has the right angle, right? Okay, so our formula for area of a square is just side squared. Okay. So I need one of the sides, but we don't have any of those. We do have a 45, 45, 90 triangle because of this diagonal right here. Very good. All right, in a 45, 45, 90, what do I label the sides across from the 45s? Good, and across from 90? Very good. All right, and which one did they give us? All right, so in other words, 24 is equal to x square root of 2. So what would we do to solve for x? There you go. So x is equal to 24 over square root of 2. We don't like to leave square roots in the bottom. So what would we do to get a square root out of the bottom? Right, square root of 2 on top and bottom. However, our final answer here is asking for the area, which we said is side squared. So if one of the sides is 24 over square root of 2, the area is 24 over square root of 2 squared, or 24 over square root of 2 times 24 over square root of 2. What's going to happen to those square roots when we actually multiply? Right, they go away. So you don't have to get rid of it here because it is going to get rid of itself further into the problem. So in the top, we've got 24 times 24, which is very good. So I got 576 over square root of 2 times square root of 2, which is just 2. And what is 576 over 2 going to simplify to? Good. So the area here is 288 inches squared. Okay, so this was okay for us to leave it in the bottom because it went away as we worked the problem. But let's say they had asked us to find the perimeter. Well, perimeter would mean I'm adding up all the sides, right? And that's not going to make this go away in the bottom. So you would need to simplify here to get it out of the bottom before we find the perimeter. Okay. All right. This last one is what kind of a shape? Very good. So our formula is base times height. Do I know base or height here? But what kind of a shape do we have inside of there? Good. All right, and again, we label those sides x, x squared root of 3 and 2x, and they gave us the 2x. All right, so 2x is equal to 15, so what does x have to be? Very good. Which would mean x squared root of 3 is going to be 7.5 square root of 3. Okay. So this would be where the 60 is. Across from that is this bottom piece, which is what we would probably refer to as the base because of how it's drawn. That's what it's sitting on. So my base would be the 7.5 square root of 3, meaning the one across from 30 would be my height of 7.5. All right, so for my area, I've got 7.5 square root of 3 times 7.5. What is that going to give us? Very good. Inches squared. So this is what I was talking about. It's okay that we have the decimal 0.25 because that's not a decimal that continued on that we had to round. So this is still the exact answer. If they asked you for the estimated answer, you could type all of this in your calculator and then it would give you some longer decimal because of that square root of 3 that eventually you'd have to round. All right. Just a few more on the back. All right, so this one is for a rhombus. They remind us that our formula for area of a rhombus is 1/2 diagonal 1 times diagonal 2. All right, for any of our quadrilaterals that have the 5 properties of a parallelogram, what do I know about its diagonals? Very good. So that would mean that if this piece is 15, then this piece has to be good. And same over here. If this piece is 20, this piece has to be 20. Right. So let's say this is my diagonal 1. How long is that? Which would mean our other diagonal is good. All right, so I would have 1/2 times diagonal 1, which is 30, times diagonal 2, which is 40. So what do I get when I multiply those all together? Good. 600 yards squared. Very good. All right. Okay, now we've got the area of a kite, which is still going to be the same formula. 1/2 diagonal 1 times diagonal 2. Okay, the difference here is that a kite does not have the properties of a parallelogram, therefore its diagonals do not bisect each other. So I can't just double it if I find one on this piece here. We do know that this line is bisected at this point, so those two pieces should be congruent. But obviously this piece that they labeled 12 and this section here are not congruent, right? They didn't give us anything on this line, right? But it is split into what kind of shapes? Right triangles, because these are perpendicular. So right here, I have a right triangle where I know this side is 12 and this side is 15. How could I find this side right here? Pythagorean theorem. Very good. So I would have 12 squared plus x squared equals 15 squared. And what's going to be my missing side? Very good. And we did say that these two pieces are congruent. So if that piece is 9, the one right beside it, also 9. So what's the length of the diagonal VT? Good. All right, so I got my first diagonal. Okay. Now for this other diagonal, I already know that this portion of it is 12. I'm just looking for this piece right here. Okay, well, we said these were all right triangles. I know this side's 13, this side's 9. What can I do to find that side? All right, Pythagorean theorem. So we got our 9 squared plus x squared equals 13 squared, or 81 from 169. And what are we going to end up with there? Huh? 169 minus 81 is
I thought you were going to
88. Okay. So I take the square root of both sides, but is there a square root of 88? No. So you're not going to come out with just a single number. But we can't turn it into a decimal either, because then at that point it's an estimation, right? So I'm going to have to simplify this myself. So I ask, what multiplies to give me 88 and also has a square root? You guys think of any number that multiplies to give us 88 and will have a square root. What'd you say? Very good. So I could rewrite this as the square root of 4 times 22 because 4 has a square root. What's the square root of 4? 2. So this becomes x is equal to 2 square root of 22. Okay, so now I know this little piece right here, 2 square root of 22. I know the rest of that diagonal is 12. What do we do to find the whole diagonal? Add those two pieces together. Good. So I got 12 plus 2 square root of 22. I cannot actually combine them because they're not like terms. Remember, we treat that square root kind of like an x. All right, so we got 1/2 times diagonal 1, which is 18, times diagonal 2, which is 12 plus 2 square root of 22. All right. Then I'm going to multiply. So I got 1/2 times 18, right? 9. And then I have to multiply that times the third parenthesis. So what's 9 times 12? 108, good. And I have to also multiply 9 times 2 square root of 22. Very good. And no units here, so just units squared. All right. Okay. In this last section, we're finding area of a trapezoid, which they remind us the formula for. It's just 1/2 times your base 1 plus base 2 times the height. Okay, so in this figure, this one right here, do we know the height? It's this one right here, right? It's got to be perpendicular to the bases, and we know that these have to be the bases because the rule of a trapezoid is that the bases are parallel, and those are the only two sides that are parallel. So this has got to be my height, and I don't know what it is, but what could we do to find it? What? It is a right triangle. So you could use Pythagorean theorem, or it's one of our triples, right? So we should have it memorized. What's that piece going to be? Good. Okay. All right, then for my bases, what are the length of my bases? Very good. So because this piece is 6, we know this piece has to be 6, therefore that entire base must be 9. All right, so we got 1/2 times base 1 plus base 2 times the height. Okay, got to follow order of operations here, PEMDAS. So what am I going to do first? Right, inside the parentheses, we add 6 and 9, which is just going to be 15, right? Then I go back and multiply those three terms. So 1/2 times 15 times 4, which is going to give us, so we end up with an area of 30 feet squared. All right, last one. Another trapezoid, so same formula, 1/2 times base 1 plus base 2 times the height. Okay, again, do we know the height here? It's the little dotted line. What are we going to have to do to find it? Right, it's another one of our 30, 60, 90s. Good. Okay, so she said that she knew that the side they gave us was the 2x, so she divided it by 2, which gives us the height of 4 across from the 30. All right. Okay, for base 1, what's my length? Very good. All right, and then for base 2, that is this entire line here. I know that part is 8.2. What do we know this piece is? Very good. It's across from what would have been the 60 degree here. So it is 4 square root of 3. So how would I find that entire base? Or just the base. Just the base. Just add them together, yeah. And then, yes, we would plug them into the area formula. So we would end up with 1/2 times base 1, which was 6.4, plus base 2, which is 8.2, plus 4 square root of 3, times the height, which we said was 4. Okay, so again, got to use that order of operations, PEMDAS. So we're working inside the parentheses first. Anything we can combine. All right, we've got these two that are like terms. So we can add those together. What is 6.4 plus 8.2? Okay, so I'm going to make a little note of that. I'm going to mark those two out and say that they became 14.6. All right, and then we just multiply now. All right, so I've got 1/2 times 14.6 times 4. 1/2 times 14.6 times 4. Very good. All right, and then we got to do the same for the one that has the radical, right? So 1/2 times 4 square root of 3 times 4. Yes. Okay, and this one was meters squared. Okay, so again, if they ask you for the exact, this is what they're looking for. If they say you can have an estimated value, that's when you can type it in your calculator and get a decimal, and they should tell you what decimal to round. Okay.